which we realized that it was a scanf, printf, sorry, it was printf that was supposed to be used in data display. And we even looked at variables. We did agree that there are memory locations, temporary memory locations within the computer. And a variable cannot stand if it doesn't have a data type. I think I'd mentioned that quite often, that a variable cannot stand if the data type is not there. Okay, so there are types of variable which we're only going to see this when we'll be looking at functions. We're only going to see that when we'll be looking at functions. That's when we'll be able to distinguish very well exactly why we need those levels of variables. Okay, why we need those levels of variables. So there are two types: local variables and global variables. We have local variables and we have global variables. So local variables will be used inside a function, and global variables can be used out of a function that created it. Okay, so local variables can only be used inside a function that created it. Okay, but global variable can be used inside the function that created it and outside the function that created it. Okay, that is the same thing that is expressed in the slide here. The local variable is in one function have no relationship to the other local variables in other functions. Okay. Then global variable exists in the entire time within your program. Okay, so it can be executed or it can be accessed from different levels. Now, I've mentioned that that will be very important when you'll be looking at functions later in the semester. Okay, so as we declare our variables, then up to that point where we'll be declaring global, I'll be able to tell you now we're using global variables, but meanwhile, we'll be declaring local variables all through as we move forward. Okay. So apart from variables, we also have constant. Just from the English perspective, we also have constant. And basically, constant is the opposite of a variable. I'll loosely say that. It doesn't really change within a short period of time. You know, variables will really change within a short period of time. Anytime you supply a new value, the previous value is overwritten and we forget about it. But with constant, they'll not change with that speed. Okay, so the speed of change or variation is really minimal. Okay, so it will stay within the memory for some time. So constant is a value that does not change during program execution. So it stays fixed until you alter your program or you change your program, for that matter. So how do we declare constants in C language? How do we declare constant in C language? We use a preprocessor directive, okay, as one of the ways we can declare our constant. And the preprocessor directive we can use in this case is normally called hash define. Hash define. So to declare constants in C language, we use the preprocessor directive hash define. An example is provided for here. Yeah. Hash define size. Hash define size. So we can also use a keyword called const. So const is also another example, another keyword that can also be used to define constant, apart from the preprocessor directive. Okay, but now we're going to introduce that as we write programs so that we'll see how it's supposed to be used. But you can just note that the keyword const, C-O-N-S-T, can also be used to define constants in C programming language. Can also be used to define constant in C programming language. So there's an example of a program there that shows how a constant can be used in defining a program. And the program is calculating the area of a circle. The program is calculating the area of a circle. Program is calculating the area of a circle.
So you are too fast.
Yes?
You are too fast. Can you slow down your speed, please?
So if you look at that program there, then it displays a new concept. There's a new concept that is being displayed there. If we give it numbers, so let the hash include stdio.h be line 1. Hash define, I'll call it pi or pi 3.14 be line 2. Okay, then let the main go to line 3. Let the main go to line 3. I think I did not capture that in my slides. Let the main go to line 3. The opening curly brace line 4. Variable declaration, that is float radius, comma area, line 5. Print f, line 6. scanf line 7. Okay, now, so before we move to the other lines, let's pause at line 7. Line 7 is scanf. Line 7 is scanf. This Linux, what should I pardon? The previous slide or what exactly? You can use the voice so that I know exactly what I should repeat. Yes, so line 7, scanf. So we have explanation to do there. So scanf is the primary input statement in C language, while printf is used for output, though display, then scanf is supposed to be used for input. So if I want to read data from the user through any input mode, whether it's keyboard, it's going to be voice, or it's whichever type of input that we're going to use, then in C language, okay, there's something Linux did not get from the previous slide. Not sure what it was. Okay. Previous slide was about examples of constants, and I did mention the type of constant that we are going to use for now. Okay, so that we don't mix everything together. That's why I would love to introduce the concepts one by one. If it is constant, then we introduce it one by one. Okay, so I'd mentioned that. So I was saying line 7. Line 7 is where I have some interest. Okay, so we say scanf, primary input statement. Now scanf will take in two parameters. Scanf will take in two parameters. One, the conversion specifier. One, the conversion specifier. And two, address of operator and the variable name. Address of operator and the variable name. That's very important for you to know that scanf will take into major parameters. Will take into major parameters. And the syntax will always remain the same. So check very well how the syntax looks like. So what is our conversion specifier in that line 7? What is our conversion specifier in that line 7? It is the %f. That's what we call the conversion specifier, and it is placed in double quotes.
Teacher,
Yes.
these lines which you're talking about, I'm not seeing the lines. Even I'm stranded. Where are those lines?
We had marked the lines before we began talking about the program. I'd said line 1, if you can see the slide that I'm using, I can say I said line 1 is #include stdio.h. I wanted you to mark it on your side so that we write together. Okay? I want you to be marking it on your side so that we write together. Because the markings that I'll put on my slide, even if you see them, they are temporary. They'll not appear in my notes later. Okay? So if you write the key points, the better. So that if you find the notes, then you can be able to relate. So I'd said #include stdio.h is line 1. #define pi 3.142 is line 2. Then I said move the main with the brackets to line 3. Let the opening curly brace be line 4. Let float radius, area be line 5. Printf be line 6 and scanf be line 7. So if I'm talking about line 7, that's the line I'm talking about. That's the line I'm talking about. Okay? So I was saying that the line has 2 parameters, conversion specifier. Then the other parameter is address of operator and the variable name. So if you look at our scenario here, I've said our conversion specifier is %f. Why is it %f? Because radius, which is our variable, was declared as float. Okay, so there's that list that I'd given previously that associate those content there. I said there's %d for integers, there's %f for floating point numbers, and there's %s or c for string or characters, so that we don't really bring a lot of concepts at the same time. We concentrate on the primary ones. The rest, we get to use them, like %i or so. We're going to use them maybe towards the end when you now know how to differentiate the one thing from the other. Okay? So it's %f because radius was declared as a float. What is this? I'm calling the address of operator. Is the and sign there. You can see the and sign just next to radius. You can see the and sign just next to radius. Okay. Then radius is the variable name. So when I say address of operator and the variable name, that's exactly what I mean. Address of operator and the variable name. That's what I mean. So you put the and sign and the variable name. So the and sign has the address where the memory location was created for the variable radius during declaration. So when you are declaring variable called radius, then there has to be some variable location that was given to it. Okay, that was given to it. So how do we access that address? It is through the address of operator. It is through the address of operator. Okay, so that's the most important thing in number 7 with scanf. So we're going to write a few programs just to ensure that you get to really understand what we mean when we talk about that. Okay. Then the rest of the program is just a bit of calculation, mathematical calculation. So you say area is equals to pi times radius times radius. And the comments there, I'm sure I'd introduced the word comment. The comment there shows that, or says that pi or pi is a symbolic constant. Okay, pi is a symbolic constant. Then the next line there is displaying the content. The next line there is displaying the content. You can see the conversion specifier there being used again. I love to mention that the way it is being used in that particular line will be different. There are several formats that you can as well use that. There are several formats that you can as well use that. I'm just going to show you one of them that is quite straightforward. The one that has been used there is showing that display area, or the value of area, in 2 decimal points. I'll say them in mathematics, okay? In 2 decimal points, okay? So the word centimeter and squared will be displayed. So the area will read something like area is 45.92 centimeter squared. Okay, so I'm going to put that program in code blocks just so that we can be able to see the display there. If you have a code block, kindly put the same in your machine so that we can be able to see the display there. Okay, so let me just bring up my code block so that we can be able to see what happens there. So there are also online compilers. Just you can check, maybe if you're using a phone, you can check. So I'd mentioned how you open up a code block, so we not go back into that. What is the error coming up, Mururi, on the slides or where exactly? Yes, which one? Which one? Expected from the lines. Expected declaration. You can you can share with me your screen. I'm trying to make mine as big as possible.
So, is it the binary code blocks or
Yes.
is it the binary code blocks?
You're asking about the version you supposed to download.
Yeah, it's the one which I'm asking.
Yes, the code block you're supposed to download should be a .exe file, executable file. Okay, that means that when you're doing the installation should be, you would double click and then the process begins. Okay, so it should not be a binary file. It should not be a binary file. It should be an executable file. It should be an executable file. So I was just trying to see how well I can be able to serve Mutuku. He's saying that the front of my screen is so small. I'm just looking at how well do I manage that. Okay, so if yeah, I'm just trying to check what you're able to view from your side with my dummy student here. So if I were to declare a variable, I'll do float radius. So I can call radius R, then I call the other one A for area. Okay. Then I can do a printf. Can do a printf there, and I say that enter the radius of the circle. I can use a conversion specifier there, not an escape code there, sorry. I can use an escape code there. Everything has to be terminated. Everything has to be terminated. I can do a scanf here. Okay. And then I say quotation %f, because we're talking about float, double quotation, comma, the AND operator. Don't confuse it with the $sign, the AND operator, R. So I'm talking about R as my radius. Okay, then I can say A is equals to pi times R times R. Okay, so you can see with me here, I'm missing the pi, so I can come back up there and do hash define pi 3.142. Okay, 142. Then what I wanted to explain is the display, the printf that is displaying. Okay, so we can say as well the area is, so this is another format that you can use to express the same thing that we saw the other side. Okay, so area. Okay, so that's another way you can use to express it. So if you look at that, then it slightly differs from what we saw the other side. It slightly differs from what we saw the other side because we are not using the 2. 2 is supposed to dictate how many decimal places do you plan to use, how many decimal places do you plan to use. Okay, so the most interesting part of this content is how do we display with printf a value and some characters. Okay, and how do we pick in some value from the keyboard using scanf? Those are the two important things for today's lecture. Are you able to understand those processes? Okay, are you able to understand those processes? How to pick in, that is reading, and how to display out a value. Okay. So you can look at more examples. Then you can, when I share the notes, you can take them and paste them in your code blocks and be able to execute them so that you can be able to see further how they're used. Okay, so you'll excuse my code blocks I think I need to zoom it using the mouse ball. And where I am, I did not carry with me the mouse. Okay. So you'll excuse my small screen. Maingi Mutuko, you'll excuse my small screen for today's lecture. That is for code blocks. You need to, I can zoom it only if I have a mouse with me. Okay. So you can proceed. So now, if once you know how to write basic programs, you need to know how to control the program. Okay. So before we can go into controlling the program, we can discuss the questions that are there briefly. So discuss 4 fundamental data types supported by C, stating how each type is stored in the memory. Okay, so there is the integer, there is the float, there is the character, and of course there is the string or double. So some of them are used interchangeably. So a string and a character, we can treat them as equal, or we can treat them as the same. Double and integer, we can treat them as the same. So we can always say float, double, and string, or float, integer, and character, whichever way you mention that. But now moving to other programming languages and moving to a different level of programming, you'll find it a bit difficult. You don't have to put them together. Programming languages will treat them as different entities. Okay, so when you talk about a string, you are not talking about a character. They'll be so different from one another. Okay. Difference between a variable and a constant, I've just mentioned that. A constant is fixed during the program execution process and will not change quite often. Unlike a variable, which is just a memory location that is supposed to be flashed anytime a new value is entered, a variable should be changing its content. How do we declare them? At this particular point, we've agreed, declaring a constant, you can use the keyword or the preprocessor directive #define. For a variable, you must use the data type and a variable name, a unique name. Okay. If I did not mention this, all variable names must be unique. Unique in the sense that they don't conflict with the other keywords in that programming language. For instance, you are not allowed to call your variable main. You're not allowed to call your variable scanf. You're not allowed to call your variable float. Okay, so they have to be unique. Apart from being unique, they must not begin with a number or a symbol. Okay, otherwise that does not qualify to be a variable name. And the third one is a variable name. If you use more than a single word, you want to use 2 words, 3 words, 4 words, don't space them. You either join them with an underscore or write them as one word. Okay, and of course, if you write them as one word, they might not make a lot of sense. So, like for instance, if you want to write student registration number, okay, the best way to do it, write student underscore registration number. Okay, student underscore registration number. That's what will make sense for most of the people. Okay. Then the next one is you suggest with example 2 ways in which constant values can be used in C expressions. Suggests two ways in which constant values can be used in C expression. Anybody who has an idea on that? Anybody who has an idea on that? Moya says, pardon. Don't know exactly. Use the sound. I'm using two different screens. The one I'm presenting for you guys, and then the slides that I'm controlling, I'll be able to scroll through. So I'll not be able to see your chat immediately. So you use the voice, the better. I'll be able to listen to it immediately. Anybody who has a suggestion? Remember, I suggest. Anybody with a suggestion? So on that slide there, it was mentioning a constant being used directly and a constant being used in directly. Directly means you use it in the mathematical expression. If it is a mathematical content to be, or value to be used, then you use it directly in a mathematical expression, just the way the 3.14 has been used there, okay? But if you want to use it indirectly, then you can use it the way pi has been used in this expression here, the one that we were talking about. Area is equals to pi times radius times radius. So that is indirectly, meaning that the value is not, it has to be accessed from a different location. You're not plugging in the value directly into that program. That will be so useful, especially when we'll be looking at how do we do what we call code reuse, okay? How do we make reuse, make good use of the previous codes? We call it code reuse, okay? What is the difference between a local and a global variable? I'd mentioned them. A local variable is declared within a function and is only usable within that particular function that has declared it. Global, declared within a function, is usable within that function and any other function outside. So it is accessible almost within the whole program. When you'll be learning object-oriented, that is C, C++, and Java, then you'll be talking about classes, okay? So an object within a class is not accessible to other different classes. Okay? So that concept will still be applicable there. Then write a program that computes the number of seconds in a year. So guys, you'll try that for me and give me an output for that. How do you compute the number of seconds in a year? I'm not saying you go and use the system time or system date. It's just a mathematical calculation. Okay, how do we get the number of seconds in a year? Mathematically, you know the number of days in a year. Mathematically, you know how many minutes or how many hours per day. Mathematically, you know how many minutes per day, and you know how many seconds per day. Therefore, mathematically, you can derive how many seconds are there in a year. So that's what the program is asking for there. That's what the program is asking for there. So of course, you'll have to know how many days are in a year, and then you convert them to the smaller units of time in hours, in minutes, and finally in seconds. Okay, So you'll write that for me. You can post it on our forum so that I can be able to look at it at a different point. Just write your version, post it on the forum there so that each person can be able to see what happens there. Yes, so the next item should be control structures. The next item should be control structures. Next item should be control structures. So once you're in a position to write in Kata, I have not said the way. Can you use the audio so that I get you right? You know, your message, when you type it and it comes to my side, I read it and I'm not able to comprehend. Like Nkata is telling me you have not said the way. How do I comprehend that? Might be a challenge. So just use the voice. Just use the voice and I'll be able to get you. Unless you have a problem with your mic on your side. Okay, so we can briefly have a look at what control structure is about. Just briefly, and I'm sure my laptop is going to go off in the next few minutes. So let's just mention it briefly. So you'll write basic programs like what we've written earlier. They are to calculate the area of a circle. You'll need to read the radius of the circle. You'll need to know what value represent pi, and then you need to just do mathematics and calculate that. But apart from that, you'll also need to know the data types and the related conversion specifiers. But now, in addition to that, your program should be able to handle existing issues in a real-world scenario. So your program should be able to make decisions. So our program becomes very effective if they're able to make a decision. They are able to change their way. And that's why concepts like artificial intelligence has really gained popularity, because what artificial intelligence is pushing for is a process where systems can learn from previous experience or from previous available data and make decisions going forward using that. If you build a robot, then you can be able to program it so that it can be able to use previous records or previous experiences to be able to make a decision. Okay, how do we sense that there's a roadblock or there's a wall in this particular path? Okay, it is through previous records that you can be able to program that. Okay, so control structures in programming are supposed to be used to change decision or to make decision. Okay, so our learning activity should be write a program that asks for the customer's purchase amount, then uses if statements to recommend the appropriate payable amount. The program should cater for negative purchase amounts and display the amount in each case. So use a nested if statement to write a program to prompt the user for a number and then reports if the number is positive, 0, or negative. Okay, so those are learning activities that you can be able to use in this discussion process. Okay, so what are these control structures? That's the question we need to ask ourselves. What are these control structures? So they are grouped into those categories. They are grouped into those categories. There's that sequence, there's the selection and decision structures, there's the iteration or looping structures. Okay, so those are structured that supports or help you control the program flow. Okay, they help you control the program flow. Some of them are repetitive structures, like if you talk about the loops, the looping structures, those are structures that are supposed to help you or help your program repeat some several steps a number of times. Okay, repeat some several steps a number of times. So there's sequence control, and then there's the selection control structures. The two are not really different from one another. Both of them really control the flow of the program execution, the flow of instruction. Okay, so we say that the sequence will control the order of execution from one element to the other. That most of the time is implemented by the compiler itself, unless now you are writing a special program that you really need to pass control of execution in a special way, maybe from one line to the other, or from one line to a different line, not in the normal sequential order in which the compiler will do it. Mule Fantas, what's the meaning of that directory? C/ty. What's the meaning of that? Is it an error you're getting, or what's the meaning of that? Okay, so we're saying the program execution is basically or is normally done in sequence. Okay, so it's normally done in sequence. So we don't really have a problem with that. As I mentioned, that is always the job of the compiler. The compiler will always implement that. Then for selection is for decision making, supports what we call alternative solutions or actions that are available. So that's where our interest is. That is where our interest is. So the first under that category is the if statement. We call it the if-else statement. It selects and make a decision. Select and make a decision. So before we go into the if-else, then we have to mention a very, very important aspect of programming: operators. Operators. Those two operators, very, very, very important in computer programming. We have the logical operators and relational operators. Okay, they are the ones that we use to make these decisions. They are the ones that we use to make these decisions. So like greater than or equal to, less than or equal to, okay, and, or, okay. They really provide us with the ability to make decisions. Okay, provide us with the ability to make decisions. So maybe I can just display a few symbols for that so that we don't forget about mentioning it again. Relational operators and logical operators. Let me just get you Now, so we'll stop there. So I've just lost my power. I think we'll stop there. Then I'll be able to upload the remaining content. So I'll upload the notes plus the remaining content. Yeah, so I'll not be able to continue. I'm using a different platform which is not able to support the lecture process. Yeah, so we'll end our meeting at that particular point. I'll upload the remaining content. Yeah, unless somebody has a question, you can ask. Any question you can ask. Okay, so if there are no concern, then we can meet on the portal. You can find the remaining content there. Now, I did mention that for those who are still on the portal, I can see guys asking about the cards. I mentioned that the card will be next week on the portal. Okay. So our cards will be next week on the portal, same time, same place. Just covering on what we've done so far. Okay. Just covering on what we've done so far. This is CCNA. No, maybe to just let you know, CCNA for this semester, there'll be two types of exams. You'll do our normal platform exams, and then you'll also do exams for ZTech University. Okay, so you'll do two types of exams. So you really need to prepare well. It's not the same day. Each CAT is done on as per the timetable of that particular unit. So if you have a CCNA on Thursday or Friday, it's supposed to be that day, not same day. But it's going to be same day with other units. If you have, for instance, today you have 3 units, then you're going to sit for 3 CATs. Okay, you're going to sit for 3 CATs. Yes. Any other concern? Yeah, no concern. Now, for analog electronics, guys who are doing analog, that is the IT students. Analog electronics, the CAT will be the same day because the lecture is on the same day. Okay, and for today's lecture, I'll do a record. I'll record, but I'll be online to answer questions, just the same way I'm doing here. So I'll be online to answer questions. I'll do a record. You can listen to it, but I'll be online to answer your questions. Yes, Maingi, there's a lot of time. There's a lot of time to prepare for your exam. There's a lot of time. Maybe I just to mention it, the CAT we are doing is not going to be so much detailed. What, in fact, part of it is we are trying to see how well you guys can be able to do your final exam without cheating. So we are trying. It's a dry run. Okay, so from the professional perspective, it's a dry run. We are trying to see how well you can take your exams without so many issues. Okay, so it's not going to be a very, very difficult CAT. After all, for structured programming, we've just covered 2 topics, so just 15 marks. Okay, 15 marks. Some of them are going to be multiple choices, A, B, C, D. Okay. Yes. So yes, one exam is coming. I'm sure maybe the communication will come from the relevant authority. How it will be done or how the modes that will be there. Okay, so that one will come from the relevant authority to communicate that. Elder Queen, are you asking about the cat? The cat is next week on Friday. Notes for CCNA, the first two topics I'm going to upload now. You can access them through the platform. Meanwhile, the registration, I'll be doing it over the weekend. So the challenge that I'm still having is you had registered with your other emails on the platform. So, but I don't want to export everybody to module 2 because I'm sure quite a number of you have not turned for the semester. They are on academic break or academic leave. So I don't want to import everybody from module 1 to module 2. So that's the challenge. I'm trying to filter those who have not come back so that we don't mix up ourselves. We don't add people who are not going to do exams in the platform, so that it will give me a lot of questions with the Cisco management. Okay. So I'm trying to filter those who have not come back so that we don't put them on the platform. But the notes, I'm going to upload them today for the 2 chapters. Okay, so see you guys. So we meet in the afternoon for analog.